example of reaction of alumina with hydrochloric acid. We obtain aluminium chloride salt, and of course hydrogen particle. In this situation, this reaction also proceeds in aqueous electrolyte solution. Also, hydrochloric acid and aluminum chloride are existing in the form of ions. Okay, so let's find ingredients. Let's find elements. It sounds better, elements that change their oxidation states. Okay, so let's start from the substrates, from the first element in the substrates that appear, aluminium. Aluminium metallic form, oxidation state equal to 0. Okay, where is the aluminium? On the right side of the reaction. Here. Aluminium here is included in the aluminum chloride salt. In this compound, aluminium oxidation state is equal to +3. Okay, so we found element that undergoes oxidation reaction. The oxidation state of aluminium is increased from 0 to +3. Okay, so we need to find element that undergoes reduction reaction. Let's check hydrogen cation. In hydrochloric acid, of course, the oxidation state is equal to +1. Oxidation state of hydrogen. Okay, let's find hydrogen on the right side of the arrow. Here we have it. Okay, in the form of particle, which is composed of 2 atoms. Every single atom in this particle, as you exactly know, oxidation state is equal to 0. Okay, so we have already found reduction reaction. Okay, to be sure, let's check the chlorine just once again. Okay, chlorine in hydrochloric acid its oxidation state equal to -1. In aluminum chloride salt, also -1. Okay, so there is no change of oxidation state of chlorine during this redox reaction. Okay, what's next? In the next step, as you know, we need to write separate Hall cell reactions. Let's start from oxidation reaction. As we say, aluminium undergoes oxidation. So, from metallic state to the cation with the charge 3+. Okay, so from aluminium to aluminum cation, and 3 electrons are released. Okay, reduction reaction. Reduction reaction, once again, as in the previous example, hydrogen cations. We remember that already at this step we need to fill stoichiometry to obtain the particle of hydrogen, which consists of 2 atoms. Okay, so aluminium oxidation reaction gives us 3 electrons. These 3 electrons should be consumed here in reduction reaction. But here we have a problem. 2 cations need 2 electrons to create 1 particle, yes? So we have a problem, and we need to balance the charge, and we need to balance, of course, the matter, yes? So how to use it? How to make it? We need to multiply both of this reaction by number of electrons which appear in the opposite reaction. So the oxidation reaction will be multiplied by 2 and reduction reaction will be multiplied by 3. So we will obtain the new reactions, I mean with the new stoichiometrical coefficients. 2 atoms of aluminum give us 2 cations of aluminum and 6 electrons. These 6 electrons will be consumed by 6 hydrogen cations because we multiplied these 2 hydrogen cations by 3, yes, and we will obtain 3 hydrogen particles consisting of 6 hydrogen atoms. Let's check the matter coefficients, the matter balance, yes? On the left side of oxidation we have 2 alumina atoms or moles, it doesn't matter here now. On the right side we have 2 alumina cations, so it is correct. In the case of reduction reaction, on the left side we have 6 cations of hydrogen. On the right side we have 6 atoms of hydrogen. So everything is correct. I didn't say you previously, I didn't say you very important information, yes, except balance of matter, the balance of charge should also be properly prepared, yes. So the left side of the charge of this half cell reaction must be equal to the right side. So let's check the oxidation state here. Let's check the oxidation state. On the left side we have aluminum. The oxidation state, the charge of this atom is equal to 0. So the charge of the ingredients on the right side of the reaction should also be equal to 0. We have cation with a charge equal to +3. We have 3 electrons. Every single electron charge is equal to -1. 3 electrons give us -3. -3 plus 3 plus give us 0. So it is correct. What about the reduction reaction? 2 cations of hydrogen give us charge equal to +2. 2 electrons give us charge equal to -2. 2 plus -2 give us 0. On the right side of the reduction reaction we have particle of hydrogen. This is neutral particle, neutral compound, so the charge, net charge of this particle is also equal to 0. The same situation below, yes, in this oxidation and this reduction reaction. Okay, so let's write the overall reaction, yes. So as I said to you previously, in the overall reaction we need to take from both, we need to take the elements and particles and or ions from both of these reactions, oxidation and reduction. So here we have a substrate, while here we have a product. Okay, so writing an overall reaction. So 2 atoms of alumina, metallic form, plus 6 cations of hydrogen give us, we skip electrons, give us 2 cations of aluminum and 3 particles of hydrogen. Yes, everything is okay. 2 atoms of alumina, 2 cations of alumina, 6 cations of hydrogen, and 6 atoms of hydrogen. And now, at this step, we could fill the electrochemical, we could fill the stoichiometrical coefficients of this redox reaction. So, in the front of alumina, metallic alumina, we write the number 2. In the front of the hydrochloric acid, we write the number 6. In the front of the aluminum chloride salt, we write 2. Yes, we have 2 particles. And in the front of hydrogen particle, we get 3. Everything is clear. The matter balance as well as charge balance is done. Okay, so let's move to the more complex, more complicated, and more experienced example.